This video will show the new tune evaluation UI that is part of Mass Hunter Quantitative Data Analysis version B.07.00. The tune evaluation UI is designed to allow easier interpretation and spectral evaluation for methods requiring tune check sample types, commonly DFTP and VFB. Additionally, we provide chromatic graphic checks. This is commonly used for semi-volatile methods, where you are looking for mass spectral integrity as well as chromatographic performance. There are two methods, basically, or two mechanisms that we use to evaluate the spectrum. Both are hands-off. One is an automated, basically do everything, and the other one is we call it manual, but basically it is just one specific evaluation mechanism. I'll show you what those are a little bit later on. This will eliminate operator-based subjectivity when determining whether you do or do not have a passing tune spectrum, and this can be automated from sequence. The tune evaluation UI can be started from batch when configured in environmental mode under the Tools menu, or you can actually create a little desktop icon. There's the target link for you, so you can fire it up anytime you want. And we do provide basic example BFB and DFTPP criteria methods. To use the tune evaluation UI, it's very, very simple. You just open your batch, select the tune check sample, and then go to Tools and Tune Evaluation. You'll make sure you load the proper criteria method and hit the Apply button, and you take a look at the results. This is a quick look here at some DFTPP performance. You can see that the low mass is failing. Surprise, surprise. And then we have some chromatographic performance as well. Now, some of the important stuff about the tune evaluation UI is that we have both auto and manual spectral evaluations. And the auto will perform all the manual evaluations and just report the results based on the closest or the best fitting. And the manual, or I should say the single evaluations, we really have three. The apex scan, which is a single scan at the top of the peak. The old CLP mandated 3-scan average, which is the apex plus or minus 1 scan, or the entire peak from start to stop. And we also have background subtraction control that can be applied if desired. And a note on finding the peak and where the background actually comes from, front, rear, and things like that. The criteria that's entered for the mass fragments is used to synthesize a spectrum, which is then used with a correlation method to find the peak in the chromatogram. So, for example, if you have a volatile run with your BFB in a full standard that has everything else in there, sometimes you can get multiple peaks that will all hit at the target ion for BFB. This will allow the algorithm to pull out the actual BFB peak and do the evaluation. So let's go take a look at the UI itself. Okay, here I have an initial calibration batch for semi-volatiles, my 20 to 160 standards, and my tune check sample type is right up top, DFTPP, right here. So I can just go to Tools, Tune Evaluation, and it brings in that file, dftpp.d, and I'll go ahead and I can make sure I have the proper method loaded. There is a dftpp.m right here. There's the criteria for the tune evaluation, and it's important to have this box checked or not, because when we do the apply, all the evaluations that are checked here will be executed. So we'll take a look here, and these are basically the spectral criteria over here, and I've chosen auto, which means we will go through all of the apex, 3-scan average of entire peak, and all the background subtraction options and things like that, and report the best one. So I'm going to hit apply, and there's the results. There's the spectrum it's found. It said it took the average of the entire peak, and it did not subtract anything, and it did use the automatic, and this is the best it came up with. Now notice here that we've got a failure. That's because the lower limit for 51 is set at 40%. This method, I really want 30%, so what I'm going to do is say edit, and I'll change this to 30. Hit the apply. Now everything is good, and all I have to do now is save that method. So dftpp.m now has been updated. Now for chromatographic performance, since this is a semi-volatile run, let's go take a look at the GC Performance Evaluation tab. And again, we've got breakdown and tailing evaluations that we'll do, and I'm going to leave both of those turned on. If this is a volatile where I didn't have any GC Performance Evaluations at all, I would leave these turned off. You don't even have to have anything in the table. But basically, I'm going to enter a compound name, the expected retention time for it, and there's a retention time window applied around there, which one's a parent compound. Again, this is for breakdown. And we're going to get him some ion information here so that, again, we can find the peak. And we're using the Agile 2 integrator in here in the run. And now my breakdown limit's 15%. And for tailing, I'm using pentachlorophenol and benzidine. These are the two common compounds used for semi-volatile tailing. Again, expected retention times with the window. What ions am I going to use so I can find the right peak? And what's the tailing factor limit? So I can just hit apply here. And let's go to the chromatographic evaluation results. And we've got a bunch of passes here. Let's see where DDT was. Okay, well there's DDT. And DDD did not find anything. Did not find anything for DDE either. And for the tailing, there's pentachlorophenol. And there's benzidine. And we do have some zoom in and zoom out here to make it a little bit easier to see things, should you desire. Now when it comes to reporting, very simple. We will create a PDF from here. That's what the report will do, and it is going to put it into, in this case, the folder, right into the data file folder. Let's see, I'm sorry, it's going to put it into the path where the data file was. I can change where I want the file name to go, but I'll just hit save. And there it is. And you can see right here, there's the DFTPP spectral report, and now we've got all the, there's some chromatographic stuff for the in this case the DDE or DDT, DDD, and DDE and the breakdowns, and then there's the information for the breakdown, and then we've got the information for the tailing. So there we go. That is the tune evaluation UI.